Hello, welcome to software testing methodology. So today I am going to discuss about another application of node reduction procedure that uses in the node reduction algorithm is looping probability of a path expression. So how we are taking the looping probability? So in that, before that, so there are, I already told you that for every application there is a arithmetic rules to be used. So those arithmetic rules is parallel, series and loop. So parallel means a plus b for path expression a, b and a sub. These are the common rules for path expression. And probability, if we are taking the probability, here the parallel rule will be defined as pa plus pb, probability of a expression plus probability of b expression. And for series rule it is taken as pa into pb, and for loop rule it will define as probability a by 1 minus probability of loop. So that is the in the loop what we have taken is weight expressions. So this is the way to define the probabilities of path expressions that are calculated by assuming all the probabilities that are present in an expression or independent, means that decision nodes are not dependent. So probabilities are calculated every decision node including loop node, assigning each outlink in a weight equal to the probability of going in that direction. Then the sum of the outlink probabilities must be equal to 1. So then whatever the arithmetic rules we have there, then those rules to be applied. So how we'll see the example. So considering the example flow graph, this is the flow graph, see here, like three cases like A, B and C. So this is the starting node, and this is the ending node. This is one case like this. From this is the starting node. From this the path expression will be started and end at this node, and again from this node the path expression will be started and end this at the B node. And from this the starting node will be started path expression, and it will go in this way and end the C node. So this is the flow graph which defines three cases: A case, B case, C case. So we have to consider that cases. Like before that, in the flow graph, the five whatever the flow graph I had defined, the sum of probabilities at each decision node is equal to unity, like 0.85 plus 0.05 plus 0.1 is equals to 1. So see this is the A case, B case and C case. Calculating the probabilities of cases A, B, C. If this is the case, what is the probability? If this is the B case, what is the probability? And if this is the case, what is the probability? So this is the original flow graph which defines the considered case A. So this is the case A which defines like A case. From this starting node to this is all the case. So see this original flow graph which is derived from this flow graph. So this is the case 0.85, 0.05 and this is the case. So from here we are taking, this is the original flow graph. From this we have to find out the probability. So see this case probability of case A. So this is all case A which is used to perform the reducing. There is a series link from this 0.306 of how it came means 0.85 into 0.9 into 0.4. This is the series link. Serial links will be multiplied. So same how this 0.459 will become in 0.85 into 0.9 into 0.6, and 0.25 how it came in 0.05 into 0.5. These are all the serial links. Next here there are all some of the parallel links to be added. Combining all serial links, there is a no operation will be performed. So here 0.25, 0.0306, this is the actual flow graph which is obtained from this flow graph. No operation. Here the operation is combining parallel links. These are all parallel links. See here, parallel links, only input links to the particular node parallel. So 0.25 plus 0.459, these two are parallel links. So that is nothing, 0.79. So and again 484, 0.484 plus 0.306, again adding will be done, 0.079. So all this can be combining parallel link, and there is serial links 0.79 into 0.8 will be defined, and here there is a parallel link also 0.632 into 0.085 is equal to 0.714. Then this is the starting node and A case ending node. So 0.717 is the probability. So this is about the considered case A. So next considering case B. So this is the case B flow graph, original flow graph. For this, we are defining this is the serial link 0.85 into 0.05, so 0.459 in, so 0.025, 0.306, what I have told in the previous slide. So this is the combining all serial links. These are all serial links. So all can be defined in this way. So again, combining parallel links. These two are parallel, like 0.459 plus 0.025 is equals to 0.484. So 0.36. Again, these two are also parallel link, means 0.79 into 0.2. This is the parallel link combining, and we have to perform 0.79 into 0.2 means 0.158. So probability of case B is 0.158. So this is case B. Next we will go for case C. So this is the case C 0.5, 0.1. This is the case C, original flow graph. So how we'll define the case C means combining all serial links like 0.5 into 0.3, 0.1 into 0.08, all this combining. This is the way when we define the combining of all serial links. This is the way to get, and we perform the parallel link. So this is the parallel link 0.1 plus 0.1, 0.01 plus 0.1 plus 0.015. So when there will perform, this is the flow graph which we obtain without any operation. So after combining the parallel links, so this is the flow graph we are defining 0.1 and 0.025, 0.8, and this defines the loop. Eliminate the unnecessary node. If there is any unnecessary node, eliminate that unnecessary node. So that is nothing but we can define one of the way to define like probability of finding case C. So 0.1 into 0.2, so like plus 0.025. This is the probability at case C. So this is about the probability, looping probability of the particular path count. So this, hope you all understand about the looping probability. So next we will go for the mean processing time. So how the mean processing time will be calculated. So in the process of finding the mean processing time, the execution time of all statements and instructions for each and every link in the flow graph is given. The mean processing time for the entire routine should be calculated. So what are the arithmetic rules here? So this is the arithmetic rules, like normal rules for path expression is a plus b, ab, a star. For weight expression is ta plus b is equals to probability of a expression, so time of A expression plus probability of B expression, time of B expression by probability of A and B. So all these are all the rules to be followed as weight expressions after defining the weightings. So how the mean processing time will be calculated in parallel rule, serial rule and loop rule. So in case of parallel path, the resultant would be the arithmetic mean of execution times of all parallel links in a flow graph. Serial loop means in case of serial path, total execution time will be the sum of all execution times in the path, like TAB is equals to TA plus TB. Loop rule means combination of parallel rule and serial rule, that is calculated based on the number of times the loop is iterated. So assuming like 3 times, the loop iteration will be 3 times. So we'll see the example for this mean processing time. So this is the flow graph. So starting node and ending node, between all these nodes consists of direct links, serial links, parallel links and loops. So 10 is nothing but a probability, mean processing time. 0.5 is nothing but a probability case. So these are all probabilities. Each link is assigned with probabilities and execution time in microseconds. So here the first application is nothing but these two are parallel links. So adding those two, like 10 plus 20, 10 of 0.5 plus 20 of 0.4 is equals to 13. So 13 is a mean processing time microsecond. So like this all will add if there is parallel links will be added, if there is serial links will be multiplied, if there is loop will be defined with star. So this is the second one flow graph which defines. Like next one is nothing but 43 which defines like 5 plus 13 plus 25 all parallel links, so will be added. All serial links will be added as 162. So all serial 37 plus 85 plus 40 in the previous diagram is equal to 160. All possible serial links are combined. So here creating inner self loop. So see here, this is the self loop. So 30 plus 20 is nothing but parallel link. So 50 into 0.6. So that is defined as a loop. This creates the self loop. So self loop means 0.6 by 0.7 into 50 is equal to 42.8. So self loop defines into like 0.6 by 0.7 into 50. So 42.8. So this is the eliminating self loop. We'll get this type of microsecond mean processing. So this is the another flow graph when we combine serial links like 43 into 93.8 into 27. So is equals to 93.8. All serial links are combined. So we'll get the 93.8. So this is last one, calculating how the calculating the mean time. So 43 to how will the 255.8 get mean? So in the previous flow graph, 93.8 plus 162 is equal to 255.8. So again 93.8 plus 27 is equal to 120.8. So this is creating self loop. Again eliminating that self loop, 0.8 by 0.4 into 255.8, 511.6. So this is the 511.6, and this is the serial link which defines 675 point eliminating self loop to get all overall reduced flow graph. So 675.4 microseconds. This is the mean time calculated for the flow graph what we have taken as an example. So this is the times like 675.4 microseconds. So this is about mean processing time to be calculated. So hope you all understand about this mean processing time, and thank you very much.